Hello y'all, how y'all doing today? This is Darrell Lee Berry Jr. with Realizing the Shape number 35. So interesting show today. So first off, uh, something came up, so I won't be available to stream live at the normal time. But due to the marvels of technology, I can make this recording and I'll have it premiere uh, at the normal streaming time. So y'all are still able to see the show at the same time. It's possible that I may have a permanent show change time in the future. But if that comes up, of course, I'll let you know. Uh, but the show today is going to be basically reviewing uh, three clips from two debates. One debate with MCToon and Nathan Roberts, and another debate with Conspiracy Catz and Nathan Thompson. So one thing I find interesting about these two debates is uh, just the facts that are presented is just so interesting. The different details and intricacies of the globe that that prove the fact that there's a globe. Um, so yeah, it's just so interesting all the different facets of the world and the way the world works and the physics works and the geometry works. That I find quite interesting. So I guess that's one of the things that uh, makes me enjoy looking at some of the flat earth debunk and flat earth debate videos as well. It's just looking at uh, just seeing all the different ways that it's evidenced and proof that the earth is a globe. There's all the intricacies of the science and of the natural world. So these two debates, McToon and Nathan Roberts, were taken on Sideman Dan's channel, and Conspiracy Catz was also on Sideman Dan's channel. So both of these are on Sideman Dan's channel. Shout out to Sideman Dan, and I'll put the link for each video inside the description for the video, as well as I'll post it now. So let's take a look at the first one, the first video here, and that's the link. It's going to be from Nathan McToon versus Nathan Roberts live debate. Let's take a look and see the interesting point that McToon puts forth on this.
My point is on rotation. I'm going to start with Foucault's pendulum, a popular thing. It is something that's easy for anybody to do, and there are many of them all over the world that you can go see yourself. It's one of the oldest things that people used to directly identify rotation. It was things that they had only indirectly measured before. The way it works is you started swinging, and you want to have it not be in an oval.
In the video.
It's actually, and south of the equator, it starts rotating. The type of thing that happens on an ellipse, on a circle, not on a flat surface. So it confirms the spinning Earth hypothesis. There are some flat Earth ideas on what causes it. A popular idea is to move somehow. Unfortunately, the same idea about the sun suggests rotation is at the Earth rotating. There are further problems. Some otherwise never heard of before force causing the rotation, right? Why would it vary with the sign of latitude? Sine and cosine functions are suggest for it is wrong. Second,
this is
weight changes based on latitude and movement. Now, the downward acceleration, typically called gravity, can be directly measured. People do this all the time. They have gravimeters. There's thousands and thousands of measurements you can look up yourself. If the Earth is spinning once a day, this force should vary with latitude. But the thing is, this is also affected by the distance to the center of the Earth's mass. And this mingled change we can control by measuring at similar elevations. We can also travel at a sufficiently high enough speed to greatly diminish or increase the net lateral speed. We can create a hypothesis for this effect, right? So we can do this right now. If the Earth is spinning about 1 revolution per day, objects weigh less because of centrifugal force in proportion to their lateral speed while at rest in relation to the surface of the Earth. If an object is moving against the direction of the Earth's spin, the net lateral speed will be reduced and the centrifugal force will be reduced, causing an increase in the object's weight. And the opposite then also, if an object is moving with the direction of the Earth's spin, the net lateral speed will be increased and the centrifugal force will be increased, causing a decrease in the object's weight. So Team Skeptic, this is going to be the ETVOS measured video. Wolfie did this with a 500-gram mass and a scale that measures to hundredths of a gram. I will put the link to this video that, yeah, there, go ahead with that. There's not much sound, so I can just talk over it. He's in a plane traveling east and traveling west. And you can see on the left, the weight is very close to 500 grams. And on the right, the weight is very close to 495 grams. It's the same weight. It's the same 500-gram mass, actually. And the weight is what's varying on these scales. So this is a nice plot showing the difference. Now, this is something anybody can do. You know, it might be difficult to bring a scale like this on a plane, but these types of scales are not too expensive. A 100th gram accuracy scale. So the video, this particular video, is just a compilation of what Wolfie 6020 did, and I put both this one and Wolfie's video in the chat, and I'll have a web page when I'm done with all this with everything in it. So the mass averaged over 4 grams lighter when traveling eastward, which increases the lateral speed, thus the centrifugal force. This supports the hypothesis. All right, and now you can stop that one. Moving on.
So I thought that was pretty awesome. So basically, what's going on is because the Earth is a globe and it's spinning, and as the flat earthers like to say, spinning at 1,000 miles an hour. But at the equator, basically, when you're at the equator, you're going laterally at about 1,000 miles an hour due to the spin of the Earth, which means being that it's a circle, just like when if you was to take like a slingshot or anything, a belt, and just twirl it around, you can feel how it's pulling away. If you let it go, it flings away. So that centrifugal force is constantly pulling away from the center when you're twirling something around. So that same force is affecting us on Earth. Basically, the Earth is basically trying to throw us off with its spin, basically. But gravity, of course, overcomes that by a large amount because rotationally it's pretty slow, only once every 24 hours. But still, there's a certain amount of centrifugal force. So if you're staying still, the centrifugal force is so much. So we'll put here 1,000 miles per hour laterally. But what happens is, if you get in an airplane, and let's say you get in an airplane and you go to the right, or with the rotation of the Earth towards the east, at 500 miles an hour, now your total lateral speed is, of course, 1,500 miles per hour. So now your lateral speed around this curve has increased, which means the centrifugal force on you has increased. So now you're lighter. But conversely, if you get on an airplane and go in the opposite direction, 500 miles an hour, now you're taking 500 off of the speed added by the Earth's spin. So now you're only going 500 laterally. So now the centrifugal force is half of what it normally is. So there's less force trying to throw you off the Earth to counteract gravity. So you're heavier. That is an awesome detail about the globe and the way it works. So I thought that was really awesome. And anyone can take a scale and get on a plane and do that. One of the things that Nathan Robbins challenged in the debate later was, the exact temperature of the plane and things like that. And so, I mean, I've been on planes before, and there's apps or applications in the plane that can tell you the speed is going and the height is going and so on and so forth. So anybody could get on a plane and bring a thermometer if that's important to you, and check with the app on the plane or check with the stewardess or whatever and find out the exact speed and height and calculate all that stuff and confirm that when you're going in one direction, if you're going from west to east, you'll the weight will be lighter. All you got to do is get a set weight and get a scale that's precise enough to measure the difference. And if you go west to east, you're lighter. If you go east to west, you're heavier because you have less centripetal force. So I think that's absolutely awesome. So thanks to MCToon for pointing that out. And be sure to go to the actual interview on Sideman Dan's channel and watch the whole thing. So it's actually a very good debate. So let's go to the next one.
So let me get to the right spot here. My topic is the sunrise and sunset predictions for a flat and spherical Earth. So I have slide 1, which is.
And let me mention, by the way, before I forget, if you'd like to be a moderator on the channel, let me know. I'll post a link into the description. And I believe when I upload this video for Premiere, it allowed me to put the link in the live chat as well as a preparation. So you could, I want to make sure like this channel is a part of my work, part of my life work, really, my research and my education and my development. So I do want it to be taken seriously. We had a few, at least I've observed a few situations where, I was giving out moderators handles as a friendly gesture, and some people I didn't feel comfortable giving it to, and but then some of the people who had the hammer were sort of banning comments inappropriately, I think, or silencing people inappropriately. So I do want to make sure that all views are allowed, as long as it's respectful and so forth. And I do want it to be handled in a professional way. And so and to be in line with my purposes of having a nice positive environment and about sharing my research and development and books and so forth, as well as just forwarding general knowledge on the topics that interest me, which of course is showing on the opening image for the channel. Out-of-body experience, basics of science, astronomy, pure non-dualism, of course, and miracles, debunking flat Earth, or which I don't do as much of now, but I do host debates on flat Earth and altered states and all of these things. And so, if you're interested, I'll put the link into the channel in the description, as well as in the live chat if I can before I leave today. And you can read about this show and what it's about and what the moderator role would entail. And let me know if you want to be a moderator. You could fill out a brief little application. But for now, I've just removed all the moderators. So there should be a sort of default screening in YouTube for any like way out of the way comments. But if you're interested in being an official moderator, let me know, and I'll just make sure that the moderators that are really official and take it seriously and respect what I'm doing and respect the people who show up and so on and so forth. So let's continue with MCToon's second point. The second point that I show here
is the flat Earth predictions for sunrise and sunset direction from Eastern Australia. I actually used a very convenient location there in Eastern Australia, of right on the intersecting lines there of -150 and 30. Sorry, positive. It's 150 east and 30 south. So you can see there that on the December 21st, these are the observed, or say that the predicted flat Earth position of the sun at sunset and sunrise. The observed time for sunrise was 5:55 a.m. Sunset was 8 p.m. So the sun was visible for just over 14 hours. So I placed the sun for sunrise and sunset at the appropriate place. And the angles then we can see are 53 degrees north of due east for the sunrise and 53 degrees north of due west for the sunset. So a significant portion there. So that's the flat earth prediction. So we can go to slide 2 to see how I developed the experiment I did to predict the globe earth angle for the sunrise and sunset at the same position. I just did the sunrise in this case because it's symmetrical. The sunset's going to just be the opposite. And then you can go to slide 3. I put a little piece of Play-Doh and a straightened paper clip, and you can see there with the stand-in sun right on the terminator line. The direction of the light is coming straight like that towards the right. And then that bottom right picture there, I measured the angle off of south of due east as 27.5 degrees. So we can go to slide 4. So now we can put in the observed, right? In in Eastern Australia, suncalc.net, you can just go in and look at the actual observed date, and then you can also question people who live in the southern hemisphere. There's 800 million of them, and if there's any in the chat, maybe you can say whether or not this type of observation matches your observation. Do you see the sun rise south of due east in the winter? In our winter, in your summer. Just to confirm, right? So this is saying that the observed sunrise was 28 degrees south of due east, or 28 degrees southeast. So we can go to slide 5. We can see the flat earth prediction is 81 degrees away from the observation. There's nothing to account for this discrepancy. All right, next slide. The globe prediction, my crude prediction, is half a degree off of observation. The measurement error of my crude model can account for this discrepancy. Therefore, our hypothesis that the flat Earth angle is 53 degrees is wrong, and the globe Earth prediction is supported. So, as according to Dr. Feynman, in that nice video, we can just dismiss the flat Earth idea, a prediction that at least using this map, right? So the problem is, of course, any other map you want to use, and you put the North Pole in the middle, you're kind of bound by where you got to put things, because we can measure latitude and longitude just by the sun position and the star position. And it's been done for, in astronomy, it's done for navigation for centuries. So people don't have much choice on where you're going to put the continents, right? If you're going to put the North Pole in the middle, then the AE map is pretty much all you can do. So we got that. Now we've got...
So I think that was awesome. So let me go back just a little bit so you can see the flat Earth position image. So anybody who's looked into this at all knows how distorted and off the flat Earth idea is, especially in the southern hemisphere. So the distance between, for instance, Africa and Australia would have to be greatly exaggerated if the if Antarctica was really an ice wall and the southern hemisphere, instead of being the bottom half of a globe, was instead split out. So, for instance, looking back at this image here, if instead of the Antarctica and Australia and Africa being, Antarctica here being at the southern pole, and Australia around here, and Africa around here. As you can see, the bottom of the globe, because it's a sphere, it's smaller in diameter than the equator. But if you split this thing out and make it into um, a flat Earth type of deal, then the distances are a lot bigger. So the lines of longitude don't match anymore. Like on the globe, the lines of longitude line up. As far as if you go from the North Pole down that line straight to what we see uh, on the globe, on let's say the eastern side of Australia, and you follow the longitude from the North Pole down to the western side of Australia. On the globe, the distance from north to south matches, and the distance in between those two longitudes will match across Australia from east to west. But on the flat Earth map, something's going to be off. Either you have to shrink Australia so it's no longer wide enough to hit that longitude, or you have to stretch Australia out super big, so now it's like way bigger than it really is in real life. So all the way it goes is not going to match up. But even farther than that, when you look at the sunrise and sunset um, from the flat Earth perspective, it just not going to match. So it makes even less sense from the southern hemisphere, because in either case, the sun will have to be, uh, let's say, in a northerly direction from Australia, when, as he's shown, the sunrise rises in the south in Australia during that period of time at the least. So this is a beautiful observation. This is basic geometry. And I know you flat earthers probably thinking, oh, that's not the real model, and so on and so forth. They present the actual model. I noticed that flat earth people, they make up some nonsense or just believe the nonsense somebody else made up because they saw it in the video where the person claimed to be a flat earther. I've seen this several times. They just play the video, and because that's what the video says, or that's what the person says, they just accept it and believe it and preach it as if they absolutely know it is gospel truth. But then when you point out how silly it is and how it doesn't add up to reality, they say, well, boy, that person's not really a flat earther, or they change it and make up something else. But one thing is definite. If it's in the time of the rotation of the Earth and the revolution of the Earth, where the sun is right over the equator, whether you call the sun a hologram, they're starting to make up now subconsciously to avoid the fact that they keep getting debunked when they give it a definite size and shape and stuff. But whatever the case is, during that period of time, for instance, in fall and spring, the sun is right over the equator, so it's straight up. So it's going to be in this general line. But still, sunrise and sunset doesn't match how it will look, how the angles will look with the sun going around in a circle like that. So as he demonstrated very, very clearly here in the summertime of Australia, when the sun on a flat Earth, it was rotating around up there, it would still be to the north, even if it was like doing some kind of wider circle type of deal. It would still have to rise north if the Earth was flat, when instead it actually rises to the south. So the only way you could account for that is if the sun gets so big in its rotation that, and it looks like my mouse being captured. It looks like it is, but let me see if I can let it be captured here. Let's just capture cursor. So hopefully you all can see it. Maybe if I move it over to this window. See if it works then to capture the cursor if it wasn't before. There we go. So even if they make the rotation of the revolution or whatever they want to call it of the sun so big that it still causes a southern uh, sunrise in Australia. Now they have to explain how the light still reaches this far, because apparently the light only goes so far, and that's what causes night and day. But if you make the sun way down here, then, for instance, the North Pole is, or North America and all that stuff is definitely outside of the distance line if the sun is on the equator, for instance. So yeah, it just doesn't add up. So I think this is an awesome um, observation that MCToon made and pointed out. And anybody can get a globe and do the calculations so themselves, but I think that's pretty awesome. So let's look at the last point. So this is Conspiracy Catz versus Nathan Thompson, and I thought this was an awesome point right here. So let's listen to this one.
Right, this is a representation of the data we gather in the real world. Now, unless your stance is going to be that we do not detect the epicenter of earthquakes, then you have to accept the science that I'm about to tell you, because this is how it works. We have P waves, we have S waves. If you don't know the difference between, hang on, just let me finish.
You're asking there.
Hang on, I can't.
Sorry, one of you cut out then. I couldn't hear what you were saying. If you just carry on the point, Catz.
If I agree that we determine the epicenters of earthquakes, right? You asked me that.
Oh yeah, sorry. So do you agree that as a human race, we regularly, with accuracy, and reliably detect the epicenter of earthquakes? Do you agree that, yes or no?
Well, science is observation of natural phenomenon and then determining cause and effect relationship. Now, according to determining epicenters of earthquakes, I will submit with great honor that I have calculated 0 epicenters of earthquakes. Now, Conspiracy Catz, because you keep using this word we, how many epicenter earthquakes have you calculated? What earthquakes were they, and how did you do it?
So I'll finish my point. We're now at the point, and this is for everyone listening in the chat, we're now at the point where, as usual, Nathan wants to take the debate into semantics of science and independent variable, and rather than actually looking at the concepts at hand, he wants to divert and strong. So I'm going to talk about the point here, and I'm just going to ignore literally everything that Nathan said there. And he can respond to the science, or what you'll see when I've explained the picture is you'll see him, again, just like I did with thermodynamics, just like I did with pressure, just like I did with trigonometry, just like I did with Polaris, just like I did with everything we've spoken about tonight, he will show literally no understanding of basic science and concepts. Okay? So when we have an earthquake, there's always an epicenter of the earthquake, and that causes longitudinal and transverse waves, as well as surface waves, but I'm just going to talk about the P and S waves here. Now, they travel through the Earth and can be detected by seismometers on the surface of the planet. Now, I'm going to say that what is in the center of that diagram there is irrelevant. I don't care what is in the center of that diagram. I'm not presupposing that, that liquid core is there or the inner core is. I'm not presupposing anything. What I'm telling you is, as an absolute fact, we do detect the P waves and the S waves being shown on the surface in exactly the same way that this diagram shows. So forget any arguments about presupposing what's inside. I couldn't give a monkeys about what's inside. We absolutely detect what is on the surface. And the thing is, it doesn't matter where the earthquake occurs. Craig, can you just switch the slide, please, to 7A?
Is that just the next one on it? So
Just the next one,
slide
mate.
8.
Oh, sorry, I meant to say it, yeah.
Slide 8. There we go.
So, all I've done here is I've taken that diagram and I've rotated it in different ways to show that the epicenter of that earthquake can happen anywhere on the planet. But what we're always going to get is exactly the same distribution of P waves and S waves across the surface of the planet. Now, if the world was flat, if the Earth was level, Right? If the Earth was a square shape or an oval shape, and you can run through every single geometric shape that you can possibly think of, just like you could with Polaris, you will never, ever find a shape that will allow this constant symmetrical distribution of P waves and S waves to occur. Those bands, those shadow bands that you can see highlighted, right, are always in the same place relative to the epicenter of the earthquake, no matter where the earthquake starts. The only possible shape of the Earth, unless, Nathan, you can surprise me and come up with a different geographic shape of the Earth, the only geographic shape of the Earth that explains this and or the observations of Polaris is a sphere. Now, rather than start replying to me by saying, I've never detected an earthquake, and strawman, because I'm calling that now, everyone in the chat will see it, can you think of a different geometric shape of the Earth that will show this? Yes or no? Go.
Yeah, it works perfectly fine on a flat surface. I want to reiterate, how many epicenters of earthquakes have you calculated? What were those? When did they happen? How did you do it? Fans, please. Because a real scientist is a truth seeker. Someone who does observations, hypotheses, and then does it. So since this is your argument,
So we can go ahead and stop with him avoiding addressing the point. So, but that was awesome. So what I did here, I took that image, that same image that we have, and I basically opened it up to show how interesting this point is. So if we look at this image here, this is basically his same image of the epicenter and the waves coming from the epicenter. So the epicenter would be in the center here. If you imagine flattening this out, so we know that the waves disperse from the center in that fashion. Is established, is recorded, is observed repeatedly with every earthquake. So what that would have to mean is, if the Earth was flat, that the waves are still somehow come from the center of the Earth, and center of the earthquake, and somehow come and radiate back to the surface like this, in this sort of fashion, right? But the distribution would still be the same, but it will somehow come down and come back up. But here's the thing: if this earthquake was, let's say, happening in Antarctica, so to pull up the image again, the video again of the sort of flat Earth map that MCToon shared earlier. So if the earthquake was to happen, let's say, in Antarctica, then what that would mean is the waves, if the epicenter was here, that means the waves on this side would have to be out here somewhere. So that means whenever an earthquake happens, let's say in Australia or in the ocean out here, the waves on this side would be out here somewhere, way away out on the other side of the Antarctic wall, supposedly. And the waves on this side, of course, would be hitting America or what have you. So what that simply means is that earthquakes prove that the Earth is not flat as a globe, because when earthquakes happen out here, just as conspiracy Catz said, when earthquakes happen, no matter where they are, the distribution is consistent around the globe. There's no instance where, as earthquakes are farther and farther towards the edge of the globe, the waves are not felt. And furthermore, what that would mean is, if we had an earthquake that was, let's say, in Antarctica, because we still feel the waves, like I said, it's not like they just don't happen anywhere. That means these waves would have to somehow, let's say if this is Antarctica, it would have to come down here, go outwards, and somehow disappear from here, and still hit out here somewhere on the other side of the so-called plane. So, but these waves that would be, if this was the ice wall right here, supposedly, these waves from the earthquake that are out here don't just disappear and we don't record them. We still record them. And what, according to the flat earth model, would be the other side of the planet somehow. So you'd have to explain how somehow the and y'all weren't seeing that illustration. Let me show the paint again. So I was saying, if this was the so-called ice wall and an earthquake happened out here, the waves would have to be way out here on the other side of the ice wall, undetectable by us. But we always see the waves occur around the globe, is always recorded, all of them. So that means this wave, if the earthquake was here, would have to somehow start to go under the ice wall, disappear from here somehow, and then appear somewhere on what would be the other side of the flat earth, way out here somewhere. So to bring up the that video again with the flat earth map on it, what that would have to mean is, if there was an earthquake around here, let's say, or in Australia, the wave, since we do still record the wave would have to somehow come right here, disappear, and somehow appear over here somewhere. So unless y'all could explain how the wave jumps the ice wall and appears on the total opposite side of the plane, especially if some people say there's a plane that extends outward past the wall and there's more land. So that means that the earthquake would be felt out here somewhere. The waves would be recordable out here. It wouldn't be recordable on this side of the other side of the plane within the wall. It just makes no sense unless y'all could explain that somehow. So many things prove and demonstrate and evidence for the fact that the earth is a globe, and it's just amazing that people are still denying it. But it's awesome that it brings up the discussion so that we have the opportunity to bring up these things and these intricacies and discuss them and explore how these things are. So let me know what you think. Let me know how you think these different details work. I think these are some awesome details of how the globe works and how it evidences for the fact that the earth is a globe, and how it shows how idiotic it is to believe that the earth is flat when all of these things are going on such a consistent basis with the way the earth works. So again, go ahead and like, subscribe, make a comment. I'll try to see if I have a moment to log on while it's being premiered to see if I can just log on and comment a bit to those who are watching the premiere. But make sure that you check Simon Dan's channel and check out these two debates in full. They're awesome debates. Let me put both of the links up in there real fast in the stream as well. Boom. So these are both of the links. One moment here. There we go. And I'll put them in the description for the video as well. Again, that's MCToon and Nathan Roberts' live debate on Simon Dan's channel. Is also Conspiracy Catz versus Nathan Thompson live debate on Conspiracy Catz channel. So be sure to check those out. And there's other proofs that they discuss, and you can see more of the idiocy of the flat earth position as well. But yeah, the points that they bring out are so awesome. Go ahead and make your live comments. Go ahead and make your comments on the video. And what I'll do this time, rather than making a live comment reply, what I may do is actually reply in comments on the video. So if you make a comment on the live chat for the premiere, or if you make a comment in the comment section of the video itself, I'll be sure to reply in the comment section to any questions or concerns. And if anybody wants to debate these points with me, if it's somebody who I've already debated, make sure that you mind the questions that you have to answer first before I debate you again. And otherwise, I might be interested in discussing with you if you, something might be fun. So cool, guys. Thank y'all for watching. I'll be back on Saturday of this week with hosting the debate between SC Montreal and Sean Hawkins. SC Montreal said he's calculated that on the globe, Baumgartner's free fall drop, he would have landed where he really landed. So we'll be interested to see what calculations he did, and if possible, proof that he actually made those calculations before Saturday of last week. But either case, what the calculations are, and you can see if they add up, and we'll see what comes of that. And in the meantime, have fun, and y'all have a nice one.